Welcome dear students. Today's video is on different problems because you are having the JEE mains test. We are doing all different doubts expressed by different students, right? And this is trigonometry part 16, right? On part of that we have the first problem: if x is equal to sine 1 radians, y is equal to sine 1 degrees, then prove that x is greater than y. This is what the problem. How we will do this particular problem? You see, my dear students, this is now here x is equal to sine 1 radian. 1 radian, you know that actually pi radians is equal to 180 degrees, and this is now pi into 1 radian equal to 180 degrees. 1 radian equal to 180 degrees by pi. Pi value, you know that that is 22 by 7, that is 3.14, like this. This value is something like 57.32 degrees. 1 radian equal to, you have got 57.32 degrees. That means x is equal to sine 57.32 around, okay, degrees, and y is equal to sine 1 degree, like this, right? Now, you know that in the first quadrant, when theta lies between, right? When theta lies between, you see here, when it lies like in the first quadrant, theta from 0 degrees to 90 degrees, you know that sine theta is increasing function. Sine theta is increasing because you know that theta, when we are having sine theta, when theta is 0 degrees, right? 0 and sine 0, 0, it is an increasing function. Sine 30 degrees 1 by 2, sine 45 degrees 1 by root 2, sine 60 degrees is root 3 by 2, sine 90 is 1. That means it is an increasing function. Therefore, when it is an increasing function, what we will be having obviously is sine 57.32 degrees. It is nearer to sine 60 degrees. That means around root 3 by 2. And sine 1 degrees, it is nearer to 0 degrees. Right, this will be obviously greater than, because this is approximately around root 3 by 2, and this is sine 1 degrees is 0.01 or something like this approximately, right? And root 3 by 2 value is greater than 0.01. Therefore, we will be getting that x is greater than y. X is nothing but sine 1 radian here. 1 radian is nothing but 57.32 degrees, and y is equal to sine 1 degree. X value is greater than y. You are going to get for this, like this. Like this beautiful problem can be answered, right? Next we have here this problem. The second problem is eliminate x from a sine of x square is equal to b cos of x square, that is equal to 2c tan x square by 1 minus tan square x square. Right? How we will try to achieve this problem, solve this problem, eliminate x. We don't have x, okay, such that we have to get a equation here. Let us observe how we are going to get it. They given that a sine of x square, right? This is equal to b cos of x square, right? Fine. They are all equal to, see, this is equal to, they given 2c tan of x square, right, by 1 minus tan square of x square. This is equal to, they are equal to some value, you take it as some k, like this, right? And from this, one more thing what I can do is nothing but sine of x square by cos of x square, this is equal to b by a, like this, right? That means tan of x square is equal to b by a. Now let us take this tan of x square equal to b by a and substitute in this equation, right? Then we see will be there any x or not, like this. That means you have got here 2c tan of x square, that is nothing but b by a, whole thing by 1 minus tan square of x square, that is nothing but b square by a square is equal to k, like this. Now this is what 2bc by a whole by a square minus b square by a square is equal to k. After simplification this, right, if you simplify this, what we are going to get? 2bc by a into a square by a square minus b square is equal to k. 1a will be cancelled. Now this is 2abc by a square minus b square is equal to some value k. In this way now it is away from x value. It is not having any x term there like that. That's why therefore it is eliminated x and you have got a beautiful equation which is not including x value. In this way you can eliminate this x value and you can do this particular problem. Now we have this problem also frequently asked. This one, third one, eliminate theta if x is equal to cot theta plus cos theta and y is equal to cot theta minus cos theta, like this. Now you have here xy, you take xy is equal to cot theta plus cos theta into cot theta minus cot theta. That is something like a plus b into a minus b, like this. A plus b into a minus b is a square minus b square. What we do is here, let cot square theta, we write it as cos square theta by sin square theta minus cos square theta, right? And you take cos square theta common in this, then it becomes 1 by sin square theta minus 1. Now this is now cos square theta and you take LCM here by 1, like this, 1 minus sin square theta by sin square theta, like this. Now this becomes cos square theta into 1 minus sin square theta is cos square theta by sin square theta. Now cos square theta by sin square theta become cot square theta into cos square theta. Okay, fine. Now they have given something like cot theta plus cos theta and cot theta minus cos theta. You do x square minus y square here. If you do x square minus y square, you will get cos theta plus sin theta whole square minus cot theta minus sin theta whole square. This is something like a plus b whole square minus a minus b whole square. That formula is 4ab. That is now 4 into cot theta into cos theta, right? 4 into cot theta into cos theta. Now by doing squaring this, now you see here what we did is we did the squaring here. That become now 4 becomes 16 cot square theta cos square theta, that equal to now, okay, already you got xy as this is equal to, actually you have got it as xy, right? This is xy, that you put it and substitute here. From that you got x square minus y square whole square is equal to 16xy. You got it as 16xy. In this way beautifully we can do this particular problem, right? We have eliminated theta and we got nicely this particular problem. See the next fourth problem. Find the value of sin pi by 4, sin pi by 2, sin 3 pi by 4, so on, like this, right? We need to find its value. How we will be doing this one is, this is what you are having here, sin pi by 4 and sin pi by 2, right? And sin 3 pi by 4. This is now sin 3 pi by 4. Here pi by 4. Pi by 4. Once again one more pi by 4 is added, then you got pi by 2. 90 degrees. For 90 degrees pi by 4 is added, then 3 pi by 4. That means 135 degrees. Now one more 45 degrees if you add, you will get a sin 4 pi by 4. That is nothing but sin pi, like this. Next, right, so on like this, sin 7 pi by 4 we have like this, right? 3 pi by 4, 4 pi by 4, sin 5 pi by 4, sin 6 pi by 4, so on like this we are having here, of course. Even if you want to write all complete terms, so then we can write. Now this is sin 4 pi by 4, this is now sin 5 pi by 4, sin 6 pi by 4, like this, and sin 7 pi by 4, like this, sin 7 pi by 4, like this. And in this particular value you can observe that sin pi value becomes 0. Now 0 into anything, these all sign, okay, 0 into anything becomes 0, therefore its value becomes 0, okay, 0 into anything, these are sin pi by 4, whatever may be the values, 0 into anything become 0, that's why this value become 0 we have got. The next interesting problem, fifth one, we have here, find the value of log tan 1 degree plus log tan 2 degree plus log tan 3 degree plus so on up to log tan 89 degrees. This is the one what we require here, like this. How we are going to, you know that actually log of, we have some results, log to the base a x1 plus log to the base a x2 plus so on like this. Okay, you have here log to the base a xn, like this you have here, like this. Now this become now what log x1 into x2 into x3 so on up to xn to the base a, like this. Therefore our problem on the left hand side, what we are having here, our problem now we can write using this particular result log, we can write as log, if nothing is mentioned, mean it is to the base 10, okay, or to the base e, no problem. This is now tan 1 degree into tan 2 degrees, right? You are going to have like this, right? Tan 1 into tan 2 into tan 3 degrees, so on like this up to tan 89 degrees, like this, right? We have got like this. And you know that one more thing we should know, that tan 89 degrees value is equal to, you can write as tan 90 minus 1 degree, this 90 minus 1 degree. That means cot 1 degree here, like this. That means you see tan 1 degree and tan 89 we can write it as like this, cot 1 degree. Therefore you see log of tan 1 degree into tan 2 degree, tan 3 degree, in between you will have tan 45 degrees, so on like this. You see we have here tan 87 degrees, tan 88 degrees, tan 89 degrees, like this, right? And this becomes, you see, log of tan 1 degree into tan 2 degrees into tan 3 degrees, so on up to tan 45 degrees value is 1 into here also tan 87 degrees. By this concept, tan 87 degrees is nothing but cot 3 degrees, because 87 you can write as 90 minus 3 degrees, tan 90 minus 3 become cot 3 degrees, and this is cot 2 degrees by the same concept, and this is now cot 1 degree. Here cot 1 and tan 1 under multiplication they cancel because they are reciprocals to each other. Tan 2 and cot 2 they will cancel because they are reciprocal to each other. Tan 3 and cot 3 they all will cancel. Now finally what is left here means, after all this is now log of 1 value. This log 1 value become what? 0. In this way we have got now this total value become 0. Log 1, that is what? 0. We have got here log 1 as 0, right? Next we have one more interesting problem. This is now the 6th one. This problem also they have asked the doubts. They are given that secant A plus tan A into secant B plus tan B into secant C plus tan C, that equal to secant A minus tan A into secant B minus tan B into secant C minus tan C. Okay, if they are equal, then we need to prove each of them should be equal to plus or minus 1. How we will be doing this? You see, once this is now you have secant A plus tan A, right, into secant B plus tan B, secant B plus tan B into secant C plus tan C, right? Okay, this is equal to, okay, you have here secant A minus tan A into secant B minus tan B, right? And this is equal to into secant C minus tan C, like this. Tan C is equal to, you take it as K, like this. You take this as K. Now what we do is, let us take K square. K square is equal to, now multiplication of that. If you multiply that, what you will get? The secant A plus tan A into this, that what you will get? A secant square A minus tan square A you will get. Into, and this one and this one, once you multiply these things, okay, this we multiplied with this thing, then only you will get K into K, K square. Then secant A plus tan A first term and secant A minus tan A second term, that become secant square A minus tan square A into another one you will have secant square B minus tan square B into, this is now secant square C minus tan square C, like this you have. And this is now K square is equal to, you know, square relation, secant square A minus tan square A is equal to 1. 1 into, this is 1 into, this is 1. That is now, from that what we can say is K square value equal to 1. K is equal to now plus or minus 1, like this. Okay, now k is nothing but what? Each of them. Okay, this one and that one. Now you proved that each one is equal to now plus or minus 1. In this beautiful way, you can able to do these problems very nicely. See now this one more problem. We have if 1 plus cos alpha, the seventh one, 1 plus cos beta, 1 plus cos gamma is equal to 1 minus cos alpha, 1 minus cos beta, 1 minus cos gamma. Then show that each is equal to plus or minus sin alpha, sin beta, sin gamma. This is also like the previous problem we do. This is now 1 plus cos alpha into 1 plus cos beta. Instead of that, okay, fine. What we do is here they given, okay, we use the information. Let us take this equal to k in the given problem. Let us take this equal to k. Now let us do k square. K square means what? K into k. If you multiply k square, that is k into k, what you will be getting is now 1 plus cos alpha into 1 plus cos beta into 1 plus cos gamma into 1 minus cos alpha, right, into 1 minus cos beta into 1 minus cos gamma. Like this we have. Now 1 plus cos alpha into 1 minus cos alpha is 1 minus cos square alpha into 1 plus cos beta into 1 minus cos beta is 1 minus cos square beta, and this is now 1 minus cos square gamma, like this. Now 1 minus cos square alpha becomes sin square alpha into this become now sin square beta into sin square gamma, like this. And you have got here now k square equal to like this, right? Now this is now this equal to actually sin alpha, sin beta, sin gamma. Okay, sin gamma whole square. Now something, if you have k square equal to some x square, means you will say that k equal to plus or minus x. K equal to plus or minus x in the mathematics, right? That means actually modulus k equal to modulus x. From that k equal to plus or minus x. Therefore here now k equal to plus or minus, in the place of x you are having what? Plus or minus. This is now sin alpha, sin beta, sin gamma, like this, right? Here in the place of x you are having sin alpha, sin beta, sin gamma. Therefore you proved each of them. Here each of them is equal to k. We mentioned that is in the beginning here, like that k is equal to, now you have got plus or minus sin alpha, sin beta, sin gamma. In this way you will be doing this particular problem. Now we have one more problem. Prove that sin square 5 degree plus sin square 10 degree plus sin square 15 plus sin square 90 degrees equal to 19 by 2. You see how we will proceed this problem, right? And in this given problem, sin square 5, sin square 90 degrees value become 1, right? Sin square 90 degrees value become 1. Now sin square 5, and the last one we are having here, I am going to club sin square 85 degrees, like this. This is as one thing like this from the given problem, because sin square 85 become cos square 5. Why? Because it is cos square 5. Why? Means because sin 85 degrees, sin 85 degrees you can write it as sin 90 degrees minus 5, and this become cos 5 degrees, like this. Therefore sin 85 become cos 5, sin square 85 become cos square 5, that become 1, like that. Let us club them and we will add them like this. Now this become 1, okay, this is one pair I made, and another one sin square 10 degree plus sin square 80 degree from, okay, this is the second one, last, but okay, 2, like this. Very good. Now like that, sin square 15 degrees plus sin square 75 degree. I am making like this pairing, like this. And another one I will make pairing, sin square 20 degree plus sin square 70 degree, like this, right? And this is now next, sin square 25 degree plus sin square 65 degree, like this we will make. Okay, next you know that, okay, we know that sin square 30 degrees plus sin square 60 degrees, this is also, right, sin square 60 degrees become cos square 30, that will be also 1. Now next one more thing, like sin square 35 degrees plus, right, sin square 35 degrees sin square 55 degrees like this. This is another pair, right? And this is now sine square, okay, 40 degree plus sine square 50 degree. Now which one is left is only sine square 45 degrees alone left, and the sine square 90 degrees is left. These both have values here like this. I told you already, my dear student, sine square 85 is nothing but this is actually cos square 5 degrees, this, because already I explained it to you. Now sine square 80 is nothing but cos square 10 degrees, this, right, like this. And this is also cos square 15 degrees like this, right? These all pairs values will give you 1 1. This is also like a cos square 20 degrees, like that it will follow, right? After following this, now this become sine square 5 plus cos square 5, that become value 1 1 plus this is also sine square 10 plus sine square 80 becomes cos square 10, sine square 10 plus cos square 10 become 1. Next this is also 1, next this is 1, next this is also 1, this is 1 totally, okay, here this is 1 you have, and this is 1. Now sine square 45 degrees is 1 by 2, 1 by root 2 whole square, that is 1 by 2, sine square 90 is 1, you are having like this. Now see here, or how many you are having here, 1 2 3 4 5 6 7 8 plus 1 9, 9 plus 1 by 2, this is now 9 plus 1 by 2. Now this is, if you take LCM 2, 9 2s are 18 plus 1, that is now 19 by 2, right? You have taken nicely the left hand side part and you got nicely the right hand side part as like this, right? In this way you will be doing this particular interesting problem, my dear students. Here you have used okay, sine 90 minus theta become cos theta, and sine square theta plus cos square theta equal to 1. By using this result you have proved this one. Next we have ninth problem in the same way. Prove that sigma r is equal to 1 to 9 sine square r pi by 18 is equal to 5. This is what we have to do. This is what they given in sigma notation. Let us write in its full form. Now r equal to 1 sigma. Then when r equal to 1, this becomes sine square pi by 18 like this. Plus when r equal to 2, this becomes sine square 2 pi by 18 like this. And r equal to 3, sine square 3 pi by 18 like this. Up to 9, we are having here up to 9. This become now sine square 4 pi by 18. And sine square 5 pi by 18 like this. Sine square 6 pi by 18 like this, right? And next sine square 7 pi by 18 like this, plus sine square 8 pi by 18 like this, sine square 9 pi by 18, right? Because r is from 1 to 9, r pi by 18. This is actually 9 1s are 9 2s are pi by 2. Sine square pi by 2 value will give you 1, right? And remaining we have here pi by 18 actually. Pi by 18 means sine. See here, you know that actually pi by 18, this is nothing but 180 degrees by 18 like this. And this is 10 degrees, right? Pi by 18 is nothing but 10 degrees. Keep in mind, this is what 10 degrees. Now, after that pi by 18 is 10 degrees means we have here, see now the left hand side part. Sine square pi by 18 means sine square 10 degrees plus 2 into pi by 18, that is now sine square 20 degrees like this. Next sine square 30 degrees like this. Next sine square 40 degrees like this. Next sine square 50 degrees. Sine square 60 degrees. Sine square 70 degrees plus sine square, what you will have, sine square 80 degrees here. Plus 1 you have here, sine square, okay, this is pi by 2, sine square 90 value is 1. Now we see we are going to do one very good nice thing here. We are going to club here. Now sine square 80, actually sine 80 degrees if you take, this becomes sine 90 degrees minus 10 degrees like this. This become now cos 10 degrees. That means sine 80 become cos 10. Now what we do is we will group like that here, like Now this is now sine square 10 degree plus sine square 80 degree. Like this we group. This is as one group. Plus next sine square 20 degrees plus sine square 70 degree. This is one group like this, right? Next sine square 30 degrees plus sine square 60 degrees. This is one other group. Next sine square 40 degrees plus sine square 50 degrees. This is one other group plus 1 you are having like this. Finally you are having here plus 1. Now I told you that sine 80 is nothing but cos 10. Okay. Now this will be transformed to, as I told you, sine square 10 plus cos square 10. Because now only I told you that sine 80 degrees become cos 10. In the same fashion, by the same process, sine square 20 degrees become cos square 20 degrees. This cos sine square 70 become cos square 20. Because sine 70 you can write as sine 90 minus 20, that become cos 20. Now sine square 30 and sine square 60, this you can write as sine square 30 plus cos square 30, like this you can write. Right, and plus sine square 40 degrees plus this is cos square 40 degrees, you can write like this, plus 1. Now this is sine square 10 plus cos square 10 is 1 plus 1 plus 1. Totally 1 plus 1 is added 5 times, you have got 5. That is what the right hand side part. Left hand side is equal to right hand side you have got. Therefore, see, you proved this result in this beautiful way, right? Now we have the 10th problem. Prove that sigma r equal to 1 to 10 cos cube of r pi by 3 equal to minus 9 by 8. How we are going to do? First, they used sigma notation. Let us expand this. Left hand side what you are having is, first one, when r is equal to 1, this become cos cube pi by 3 plus sigma means summation plus r is 2 means cos cube 2 pi by 3 like this plus next cos cube 3 pi by 3 like this plus cos cube 4 pi by 3 like this. Sorry, okay, fine, like this cos cube 5 pi by 3 like this, so on up to cos cube 10 pi by 3 like this. Okay, because r is 1 to up to 10 pi by 3. Actually cos cube pi by 3 means what? 60 degrees. Now this is cos cube 60 degrees, cos cube 120 degrees, this next cos cube 180 degrees like this, next cos cube, okay, 4 into 60, that is 240 degrees like this, so on like this. Cos cube 10 into 60 degrees, that is nothing but 600 degrees like this, right? Cos cube 60 degrees is 600. It is here very simple, you just write these values and sum it up, you will be getting this problem very easily like this. Cos cube 60 degrees, cos 60 degrees, you know that 1 by 2 whole cube, this 1 by 2 whole cube. Just writing these values and putting there, we will be getting cos 120 degrees value you have here. Cos 120 you can write as, actually you see here, it is only the way you just need to find. Now cos 120 degrees here, cos 120 you can write as cos 90 plus 30 you can write, this become minus sin 30 degrees, right? And this become minus 1 by 2, right? And this is now plus of minus 1 by 2 whole cube, you can write like this, right? Because cos 120 is cos 90 degrees plus 30, that become minus sin 30 minus 1 by 2. Therefore cos 120 is minus 1 by 2 whole cube like this. Next cos cube 180 degrees, that become cos 180 degrees value become minus 1, this is now minus 1 whole cube. Next cos cube 240 degrees. Now cos 240 degrees, how you will do? This is cos 270 degrees minus 30 degrees, you can write 270 minus theta, it is in third quadrant, therefore it become minus sin 30 degrees, right? And this is minus 1 by 2, this become minus 1 by 2 whole cube like this, right? Cos cube 240 degrees you written like that, right? Plus cos cube, actually this is 60, 120, 6 into 2, 60 into 3, 60 into 4, 60 into 5, cos cube 300 degrees. Next, okay, cos 300 degrees, right? In this way, my dear students, this is very simple. Cos 300 degrees, this you can write as 360 degrees minus 60 degrees, like this, right? Once you write cos 360 minus 60, it is in fourth quadrant. This become cos 60 degrees, that is 1 by 2. That is nothing but now 1 by 2 whole cube, like this, right? So if you do this and simplify like this, so on, you have like this still cos cube 600. Even cos 600 degrees, you know how to do this. Is cos 600 is cos 720, okay, minus 120 you can write. 2 into 360 degrees. This is now, okay, cos 120 degrees value. And cos 120 degrees value become cos 90 plus 30 degrees and minus sin 30 degrees. This minus 1 by 2. Like this, the last one is minus 1 by 2 whole cube. Like that, my dear students, you know how to do this. You just sum it up and finally you will be end up with minus 9 by 8 will be the answer for this. Just you sum it up, so on, like this. Nothing logical here, just finding the values and sum it up. This is become 1 by 8 and this is minus 1 by 8, minus 1, minus 1 by 8, plus 1 by 8, minus 1 by 8. You just do that and sum it up, you will end up with that particular answer. It is very that I am leaving it as an exercise to you. You have to do that particular one. Now see this particular very interesting problem, 11th one. If sin x by a equal to cos x by b equal to tan x by c equal to k, then show that bc plus 1 by ck plus ak by 1 plus bk equal to 1 by k times of a plus 1 by a. This problem, how we will be proceeding, you please observe. They given that here sin x by a equal to k, then a is equal to sin x by k, and cos b is equal to cos x by k, and c is equal to tan x by k, like this. C is equal to tan x by k. Now they let us take the left hand side part here, right? The left hand side part you have here bc plus 1 by ck plus ak by 1 plus bk. Okay, now let us see here. B is nothing but what? Cos x by k, cos x by k into c is nothing but what? Tan x by k, tan x by k, right? Plus 1 by ck, 1 by c is what actually? Yeah, c is what actually? Tan x by k, tan x by k into k. Into k means this k and this k will be cancelled, like this. Plus you are having here ak. A is what? A is sin x by k, sin x by k, right? ak into k, this k will be cancelled, and by 1 plus bk, 1 plus b is nothing but cos x by k, cos x by k into k, like this k and this k will be cancelled. Now see here, beautifully we have got here, this is now cos x into tan x equal to sin x by cos x, right? Now this become, you see, cos x by k into, this is k into k square into, this is now sin x by cos x, right? Wonderful. This cos x and this cos x will be cancelled, and you have got here plus 1 by tan x, right? 1 by tan x. 1 by tan x you can write it as how? Right? 1 by tan x you are having here. That you can nicely write as like this. Fine. Everything we convert because these are all in sin and cos. 1 by tan x is cot x. That we write it as cos x by sin x, like this. Right? Fine. Next, plus you are having here this k cancelled here, sin x by 1 plus cos x. You are having sin x by 1 plus cos x. Right. Now like this we have here. Fine. Now this is 1 by k square into, right? You have got like this. Now let us try to simplify this. So this is actually we have here sin x by k square, sin x by k square plus, and let us take here the LCM, right? If you take the LCM here is what? Sin x into 1 plus cos x, sin x into 1 plus cos x, This is what the LCM. Then what you will be having is cos x into 1 plus cos x. That become, now I am writing directly cos x plus cos square x plus sin x into sin x. That is now sin square x. You are having like this. Right? Fine. Now you see, my dear students, this what you are going to have, this from here, sin x by k square, sin x by k square, and this become cos square x plus sin square x become 1. Therefore this is now plus 1 plus cos x, 1 plus cos x by sin x into 1 plus cos x. Wonderful. This will cancel now like this, right? Wonderful. Once this is cancelled, what we have left over, now let us write here. See, you please observe till this what we have written. There is no space. Now I will erase it and do here now. Write, this is what I am erasing here. Now you have got this total thing is nothing but sin x by k square plus, right, 1 by sin x I have got like this, 1 by sin x, right? Fine. And we know that right, sin x by k square plus 1 by sin x, that is nothing but actually sin x is equal to, from this you know that what, ak by k square like this, because sin x equal to ak plus 1 by sin x. 1 by sin x is nothing but sin x equal to ak. Now 1k here, 1k will be cancelled, a by k plus 1 by ak. Now 1 by k, if you take common, you will be getting that a plus 1 by a like this, right? And thus is equal to the right hand side part. You have taken the left hand side part and you got the right hand side part like this, 1 by k times of a plus 1 by a, right? In this way you will be getting this beautiful problem, 1 by k times of a plus 1 by a, right? Fine. Next we have one more very important problem, 12th one. If x is equal to 2 sin theta by 1 plus cos theta plus sin theta, then express 1 minus cos theta plus sin theta by 1 plus sin theta in terms of x. This is what the problem, very beautiful and important problem on competitive point of view. Let us see here how we are going to do. We have got here x is equal to 2 sin theta by 1 plus cos theta plus sin theta, right? This is what the problem. We need to express this now in terms of x. For that what we do is we multiplying x, okay, numerator and denominator by 1 minus cos theta plus sin theta, okay. We multiply here 1 minus cos theta plus sin theta like this, and here also 1 minus cos theta plus sin theta like this, right? Once you do like this, right, yeah, what we are going to get, once we do like this, what we are going to get is here, this is nothing but of course 2 sin theta into 1 minus cos theta plus sin theta, whole thing divided by, right? And this is here one thing you can observe here, 1 plus sin theta, okay, this I can write as 1 plus sin theta whole square minus cos square theta like this, right? See, actually we can write this 1 plus sin theta as a and plus cos theta, that become b. You see here 1 plus cos theta plus sin theta, we can write this. Okay, this is actually we have written as 1 plus sin theta plus cos theta into, this is 1 plus sin theta minus cos theta. Now what I did is, this is a plus b and this is a minus b like this. A plus b into a minus b is a square minus b square. Now see, this is what, a square minus b square. Like this we have written. Okay, fine. Okay, now here this is now 2 sin theta into 1 minus cos theta plus sin theta by 1 plus sin theta whole square. This cos square theta we write it as 1 minus sin square theta, right? Now you see in this we can take common 1 plus sin, this 1 minus sin square theta we can write as nicely 1 minus sin theta into 1 plus sin theta, right? Like this we can write nicely. And in this 1 plus sin theta is common, we can nicely take common. Now this become actually 2 sin theta 2 sin theta into 1 minus cos theta plus sin theta whole thing divided by, here 1 plus sin theta if you take common, here 1 plus sin theta if you take common, right? And here you have 1 plus sin theta, here 1 plus sin theta is taken common, minus 1 plus sin theta you will be having like this, right? Fine. Now this becomes, what happens is now 2 sin theta into 1 minus cos theta plus sin theta whole thing divided by, this is now 1 plus sin theta into, here 1 minus 1 that becomes 0, sin theta plus sin theta that become what, 2 sin theta, like this. Now this 2 sin theta will be cancelled, and you have what now, this 1 minus cos theta plus sin theta by 1 plus sin theta. This is nothing but what, you have taken x and you have what, same x, or 1 minus cos theta plus sin theta by 1 plus sin theta is nothing but same x. If this is x, that is also x. In this way we will be doing this beautiful problem, and please watch, and I will release more videos on different kinds of problems. Thank you for watching. Please subscribe, my dear students. Please share it. Thank you very much.